Okay, talking about measures of dispersion is our continuation of statistics today. Okay, so measures of dispersion are going to be the topic for this video. First measure of dispersion is the range. That's how big the set is, really. Okay, and that's just going to be the difference between the max and the min. All right, and that's a pretty basic one you've been doing for a while. Interquartile range, or IQR, is the distance between the upper quartile and the lower quartile, or the difference between Q1 and Q3. Okay, and these are always going to be positive numbers, so you'll take Q3 minus Q1, and that's how you find the interquartile range. To determine if a set has an outlier, the technical definition of an outlier basically is somebody that's way outside, really different from anybody else in the set. Okay, but there's like a technical definition for statistics of an outlier. An element of a set K is an outlier if and only if, okay, K is less than K is less than Q1 minus 1.5 times the IQR, the interquartile range. Okay, that would be an outlier to the lower end of the scale, and it works the other way as well. If you go 1.5 times the interquartile range above the upper quartile. And just kind of an illustration, I kind of like the box and whisker plot, just kind of illustrate outliers for a second here, right? Like if I take a box and whisker plot, it's got whiskers out here, right? And it's got a box. We'll just start the box right there. It doesn't really matter where the median is, okay? What I know is I have Q1 here, and I have Q3 here, okay? Grab all this guy here, put them more towards the middle, all right? Put them together, group it, all right? And we'll just kind of shrink them down a little bit. There we go. All right, now the interquartile range is actually going to be this distance right here. This is the IQR. That's what that distance is. It's Q3 minus Q1, okay? So an outlier would be a data set that's like way out here. And what it has to be, all right, well, here's one of them, right? And then if I do a half of one, I do a half of an IQR. So I want it to be 1.5 times the interquartile range, okay? I'll just put those guys together, okay? Those, right? So we're talking about being 1.5 times bigger, or 1.5 interquartile ranges above Q3, which unfortunately, the way I'm drawing my picture here, I can't show you where that would be. It'd be way over here, right? That's why it's an outlier, okay? Like an outlier would be a data set that like falls way over here, right? And another one, right, would be like if I was doing 1.5 interquartile ranges below Q1. Okay, so that's what an outlier technically is. Okay? All right. The table shows the number of minutes, rounded to the nearest 5 minutes, needed for each of 100 people to complete a survey. Find the range and the interquartile range for this set of data. Now the range is pretty easy, right? The range is pretty easy. All right, it's going to be the biggest amount of time, right, here, which is 85, minus the smallest. So the range is just 55, all right? The interquartile range, well, that's going to require a little bit more work. I need to know what Q1 and Q3 are. Okay, if there are 100 scores, all right, the median is between 50 and 51, right? It's between 50 and 51. So when you look at the cumulative frequency, 50 and 51 both happen in here, all right? So 50 and 51 are both in this area for the cumulative frequency, right? Which is 55 minutes, all right? So the median is 55. So the interquartile, the first quartile is going to be between the 25th and 26th, okay, which is in here, 25th and 26th. So I see Q1 is going to be 45, all right? And then the upper part, it's between the 75th and 76th, right? 75th and 76th, which falls right here, 75th and 76th, cumulative, right? So Q3 is 60. So the IQR is 60 minus 45, or 15. All right, now it asks, does this data set include outliers? Okay, well, this will have an outlier if I have something that's 1.5 times the interquartile range below Q1, so 45 minus 1.5 times 15, or it's got to be below that, K would be less than that, or if K is greater than 60 plus 1.5 times the interquartile range, which was 15, right? And this 1.5 times 15, 1.5 times 15, whoops, I quit. 1.5 times 15, and it's not 22.5, sure. Okay, 22.5. So either K has to be less than 22.5, or K has to be greater than 45 minus 22.5. Let me write it out. Or K is greater than 16 plus 22.5. And so that's K greater than 82.5. And this is K less than 22.5. So when you look at the things in my data set, the min is 30. So I don't have any less than 22.5. So I'm not going to get any outliers on that end of it. But then if you look at the other end, right? Look at the other end. Do I have anything greater than 82.5? I sure do, right? I had this one guy that took 85 minutes. So the answer to B is, this is for B, right? The answer to B is yes, 85 is an outlier. There we go. Okay. So that's how you can kind of determine if a set has outliers and what they would be. All right. Variance. Now we get into the standard deviation of variance, which is a typical Regents question. And the variance is just a measure of how spread out the data is from the mean. I mean, is it all really close to the mean? Then it's going to have a very small variance. If it's really spread out and dispersed, then it has a large variance. The variance of a sample is given there, all right? And if it's a sample, they use the notation S of x, right? S of x squared for the variance. And for a population, they use sigma x. That's the lowercase sigma, okay? Sigma x squared, all right? And unless we're told that it's a sample of a larger population, you're going to use the population. All right, unless it says find the sample standard deviation or the sample variance, use this one on the right here, okay? Standard deviation is equal to the square root of the variance. All right, so I want to calculate the variance and the standard deviation for the set. And I do have to fix these a little bit. These should have x bars. These are means on those. So make sure you get that on your formulas for your variance, either sample or population. All right, calculate the variance and standard deviation for the set. Does it say sample? No, it just says set. So in my world, that's the entire population. 1, 3, 4, 6, 9, and 19. Okay? 1, 3, 4, 6, 9, and 19. All right? So there's a couple things I'm going to want. Right? I'm going to want to know the mean. Okay? I'm going to want to know the mean. That's 1 plus 3 plus 4 plus 6 plus 9 plus 19. All right? Divided by, there are 1, 2, 3, 4, 5, 6 of them. Okay? So 1 and 3 is 4, 4 and 4 is 8, 8 and 6 is 14, 14 and 9 is 23, 23 and 19 is 42. And it's 42 divided by 6, which is 7. Okay, so the mean is 7. All right, so to find the variance, all right, I have to do the sum from I equals, how many of them are there? 1, 2, 1, 2, 3, 4, 5, 6. This 1 to 6 of x sub I minus the mean, which is 7, squared, okay, over the total number of elements, which is 6. Okay, there we go. I'm substituting in x bar and n into that formula. All right, and we've done stuff with sigma notation before, right? We're just going to add up. What is x sub I? What is x sub 1? Well, x sub 1 is 1. X sub 2 is 3. X sub 4 is 6. Where are these coming from? Well, it's the first, second, third, fourth, and so on, okay? So what I have to do is I now have to sum these numbers, right? I got to do 1 minus 7 squared, all right, over 6 plus, and then 3 minus 7 squared over 6 plus 4 minus 7 squared over 6. I should have moved this down here. So I have room to put it all kind of in one spot. Just kind of continuous line here, okay, plus, what's the next one? 6 minus 7 squared over 6 plus 9 minus 7 squared over 6 plus 19 minus 7 squared over 6. Okay, so that right there is the variance, right? That is the population variance, which, reminder, is sigma x squared. Okay, so 1 minus 7 is negative 6. When you square that, you get 36. And these are all over 6, so I can kind of just put these all over one big 6. You have to keep the denominator and add the numerator. 3 minus 7 is 3 minus 7 here is 3 minus 7 is 4, negative 4 squared is positive 16. And these are always going to be positive numbers up here because you're going to evaluate it first and then square it. Whether it's positive or negative, if I square that, it's going to be a positive number. Okay, 4 minus 7 is negative 3 squared is 9. And then I've got 6 minus 7 here. 6 minus 7 is 1. Negative 1 squared is 1. 9 minus 7 is 2. 2 squared is 4. And then 19 minus 7 is 12. 12 squared is 144. There's a big boy. Okay, there we go. Now we add those up and divide by 6, and that will give me my variance. Okay? Probably could do it without a calculator, but save a little time. 144 plus 4 plus 1 plus 9 plus 16 plus 36. Okay, and that gives me 210 over 6. And 210 divided by 6 is 35. So, the variance is 35. Now the standard deviation, that's just going to be, if I take the square root of both sides of that, that's going to give me the standard deviation. So I can write it as the square root of 35, or I can take the square root and get it as a decimal answer. 5.916. All right, now you may have noticed when we were doing some stuff earlier with statistics that we had, we did these like single variable, one variable stats, that sigma x and sx were listed on our list of goodies that we had. Right? I've got some data in here already probably. No, not really, okay. 22.5, 26, 58, 96. Okay, if I put some things into L1 like this, and I go to stat and I calculate single variable stats, okay, all right, and then hit enter, there they are right there. See, standard deviation, 29.6. If you wanted to know the variance, you would then square that. The calculator doesn't give you variance, I don't believe. It's not one of the goodies that it gives you. Okay, so you can do it with your calculator, which is really nice to know. Okay, all right, what do we got next? There's one example of that. All right, for that data set, construct a 5-number summary, find the range and interquartile range for the data set. That's a review. What is the standard deviation? What is the variance? And I think that's probably all we're going to have time for on the video. We'll probably hit this page in class tomorrow. Okay? All right, so, Monday. All right? So, good luck, and I'll see you Monday.